All right, so let's get started with number 11 on our spring break packet. It's a circle equation, so we've done a lot of practice. I think we actually already did this question in class once. Let's take a look. We're given the endpoint of the diameter of the circle, and we have the equation. We want to know the y-coordinate of the other endpoint. So we might not be sure what to do, but we always know it helps to find the center and the radius of a circle. So let's go ahead and take a look. I don't have any graph paper, but it helps to have a graph. So let's just make a quick graph. And we're going to put the endpoint, which is 3, -6. So I'm going to go 1, 2, 3 to the right, and 1, 2, 6, something like that. Okay, so this is our endpoint of the circle, but we don't know exactly where the circle is. So having the center of the circle will help us. It's not in parentheses, it's not factored, so we're going to use completing the square as our method. So I'm going to go ahead and copy it down first. Okay, so here is our equation. And now remember, we're going to complete the square by grouping our x's. So I have x squared minus 6x. Then I'll leave a space. Y squared plus 2y. And a space. And the 15 can stay over on the right side of the equation. Remember, we're going to take 1/2 of b and square it. So half of 3 squared is 9. Half of 6 is 3, 3 squared is 9, and half of 2 is 1, 1 squared is 1. So I added 9 and 1, I'm going to add 10, or 9 plus 1 to the other side of the equation. Alright, so now we can put this in our factored form. And remember, this will always be 1/2 of b, same sign. Alright, so now that we have this form, we know that the center of the circle is going to be 3, -1. We also know that the radius is equal to 5. So if we put the center on our graph, it's right here. This is the center, so that works out. It's on the same x. So we can imagine that the circle is this way, right? And since our radius is 5, we start at -1. And if we count up 5, 1, 2, 3, 4, 5, our other endpoint is going to be right there. And that is 3, 4. So that's it. And the question is, what is the other y-coordinate? So the y-coordinate is 4. Our answer is C. Alright, so that was a pretty easy one. Let's check out number 12. Next, this has to do with some similar triangles. And what we know about similar triangles, we can write this down. When we have similar triangles, we know that the angles are all congruent, or corresponding angles, I should say. I'm going to erase this and write corresponding. We know that corresponding angles are congruent. We also know that sides are proportional. So those are the two things you want to keep in mind. Remember, a proportion looks like this, right? So let's take a look at this question. The figures shown are 3 similar triangles. Okay, so they're all similar to each other. Find the values of cosine F and cosine eye. That looks like an eye. All right. So what we know is if the angles, the corresponding angles are congruent, that also means that the sine, cosine, and tangent of congruent angles are also congruent, are also equal to each other. So let's start with, we want the cosine of f and I. Well, f is this angle, and I is this angle. And we have to look at the triangle that has measurements. Which is the corresponding angle to f? That's B. So B and F correspond. And actually, I and B also correspond. So if we find the cosine of B, we also know the cosine of F and I. So let's go ahead and do that. Cosine of B is equal to the cosine of F, which is also equal to the cosine of I. Well, cosine, remember, SOHCAHTOA. Cosine is A over H, adjacent over hypotenuse. So let's see, the adjacent side here is 15. All right, this is the adjacent, it touches the angle. And the hypotenuse is 17. So that means that the cosine of B equals 15 over 17. And that means that cosine of F and cosine of I are also equal to 15 over 17. So here we go. Cosine of F, 15 over 17. Cosine of I, 15 over 17. Also a pretty easy problem. All right. Let's go ahead and go to our next question, number 13. Let's check it out. Okay, it looks like another transformation question. We have two quadrilaterals. Number 1 is the pre-image, and number 2 is the copy or the image. The question is, which transformation on quadrilateral 1, the original, can be used to verify that it is similar? Well, they are similar if there has been a dilation. So we have to pick which dilation is correct. All right, so first of all, the most important thing with the dilation is figuring out the scale factor, right? We can see scale factor. Which is it? Is it 1/2? Is it 3/4? Or is it 2? So let's talk about the scale factor. So we said the scale factor, one way to find it is we can choose a side and we can divide the copy by the original. So here we can easily pick these horizontal sides. So remember, we go from 1 to 2. So it's getting smaller. We start off at 6 and we go to 3. So that we can think of it as the copy is 3 and the original is 6. That's one way to think of it. 3 over 6 is equal to 1/2 if we simplify this fraction. 3 divided by 3 is 1, 6 divided by 3 is 2, and obviously 3 is 1/2 of 6. So the scale factor is 1/2. We can also think of it as we're going from 6 to 3. So what happened here? We divided by 2. And remember that divided by 2 is the same thing as multiply by 1/2. So our scale factor is 1/2. So we automatically know that it is not C and it is not D. So the question is the scale factor centered at the origin, or is it centered at another point? So one thing we can write on our paper to remember is that when we have a dilation about the origin, which is 0, 0, we just multiply the coordinates by the scale factor. So if this works, if we can just multiply the coordinates by the scale factor, then we know that the origin is the center of dilation. But if it does not work, then it has to be another point, and our only option would be B. So let's pick a point. I'm going to pick this one right here. Start here with number 1, negative 8, 6. So negative 8, 6, after the dilation, goes to this point, negative 4, 3. And we can see that 1/2 of 8 is negative 4, and 1/2 of 6 is 3. So if we just use the scale factor, we get the point. So that means that the center is the origin. Let me give you an example of when it would not be. Say we have negative 6, 8, and then we get negative 5, 2, right? This will not work because 1/2 of 8 is not 5, 1/2 of 6 is not 2. It's still a dilation, possibly, I didn't check, but that means that the center of dilation is not the origin. So this would not work. All right, so since it did work, we know that the scale factor is 1/2 and it's centered by the origin, so our answer is A. All right, that'll be it for this video. See you on the next one.